circular motion. Part 3. What is centripetal force? It is denoted by CPF. The options are A. A specific type of force like gravitational force. Second, B. A pseudo force directed away from the center. Option C. A property of a resultant real force directed towards the center. Or option D. An imaginary force that balances the centrifugal force. And the correct answer is option C. A property of a resultant real force directed towards the center. And its explanation: the word centripetal is not a name or a type of force, but rather an adjective or property describing the direction of a resultant real force which is along the radius, and very important, it is towards the center. Question number 2. According to the provided text, you refer Navneet's textbook. What is the resultant of all the real forces acting on a body in a circular motion? We are supposed to find the resultant of all the real forces. Option A, 0. Option B, tangential to the circular path. Option C, directed away from the center. And option D, directed towards the center. And the correct answer is option D, directed towards the center. Explanation: the text states that during circular motion, the resultant of all the real forces acting upon the body must be directed towards the center, and this is what we call the centripetal force. This is real force and it always directed towards the center. Question number 3. Which of the following equations represent the magnitude of centripetal force? Option A, centripetal force is equal to mv omega. Second option, CPF is equal to m upon r omega square. C, CPF is equal to mv upon r. Or the last option, CPF is equal to mr omega square upon v. And the correct answer is option A, centripetal force is equal to mv omega. Explanation: the text provides the formula for the magnitude of the centripetal force. mr omega square is equal to rmv square, or which is equal to mv omega. Question number 4. In which frame of reference is centrifugal force considered as pseudo force? Pseudo force means not a real force. Option A, an inertial frame of reference. Option B, a non-inertial frame of reference that is undergoing centripetal acceleration. Option C, a frame of reference where the resultant real force is 0. Or last option is option D, an imaginary frame of reference. And the correct answer is option B, a non-inertial frame of reference that is undergoing centripetal acceleration. Explanation: centrifugal force is described as a pseudo force, which is not a real force, that arises due to centripetal acceleration of the frame of reference, such as merry-go-round. This is the example. So the correct answer is option B. Question number 5. What is the direction of centrifugal force? Option A, towards the center of circular path. Option B, tangential to the circular path. Option C, away from the center of the circular path. Or option D, perpendicular to the plane of motion. And the correct answer is C, away from the center of the circular path. Explanation: the centrifugal force is defined as the force directed opposite to the centripetal force, which is away from the center. This term centrifugal literally means away from the center. Hence, centrifugal and centripetal, they are opposite to each other. Centripetal means towards the center and centrifugal means away from the center. Question number 6. How does the text describe centrifugal force? We will denote it by CFF. Option A, a real force that is equal and opposite to the centripetal force. An imaginary force used to explain motion. Option C, a non-real force that is not imaginary. Or option D, a resultant of all real force acting on a body. And the correct answer is option C, a non-real force that is not imaginary. document clarifies that the centrifugal force is a non-real force, but it is not an imaginary force. It can be measured, for example, by a force measurement instrument. So always remember, it is a non-real force, but it is not an imaginary force. Question number 7. In the frame of reference of a merry-go-round rotating uniformly, what happens to the centrifugal force and the resultant of all real forces? Option A. The centrifugal force is greater than the resultant real force. Option B. The resultant real force is greater than the centrifugal force. Option C. The centrifugal force exactly balances the resultant of all real forces. And the last option, option D, the resultant real force and the centrifugal force are both 0. And the correct answer is option C, the centrifugal force exactly balances the resultant of all the real forces. Explanation. In the frame of reference of a uniformly rotating merry-go-round, the centrifugal force exactly balances the resultant of all the real forces, making the resultant force in that frame 0. Question number 8. What two forces are acting on a car on a horizontal circular track according to the text? The first answer is option A, centripetal force and centrifugal force. Option B, weight and normal reaction. Option C, weight, normal reaction and centripetal force. And last option D, weight, normal reaction and friction. And the correct answer is option B, weight and normal reaction. Explanation. For a car on a horizontal circular track, the force acting on it are described as its weight mg, which act vertically downward, and the normal reaction capital N, which act vertically upward and balances the weight. Please refer the text any of the figure and you can see these two forces, they are opposite to each other. Mg is in vertical downward direction, whereas the normal reaction is in upward direction. Question number 9. What is the essential for a motion to be a circular in addition to a resultant force directed towards the center? Option A, zero tangential velocity. Option B, a constant centripetal force. Option C, a correspondingly matching tangential velocity. Or option D, a changing angular acceleration. The correct answer is option C, a correspondingly matching tangential velocity. Explanation. For a motion to be a circular, a correspondingly matching tangential velocity is also essential. That is essential thing needed for the motion to be a circular, in addition to the resultant force directed towards the center. Question number 10. What force is causing the spring balance to read more mass when drilled in a horizontal circle? Option A, centripetal force. Option B, gravitational force. Option C, centrifugal force. Or option D, normal reaction force. And the correct answer is option C, centrifugal force. The activity describes involve whirling a spring balance with a mass attached, which causes the balance to read a higher mass. This is due to outward pull or centrifugal force experienced in the rotating frame of reference. Hence the correct option is centrifugal force.